module. You will learn about water and its properties. We all know that water is essential for the survival of all forms of life. It forms a major part of all living organisms. 60% of the human body is made up of water. And in some plants, this quantum goes up to 90%. Water covers 71% of the Earth's surface. However, the distribution of water over the Earth's surface is not uniform. Oceans contain 97.33% of water on the Earth's surface. Only 2% of water on the Earth's surface is in the form of polar ice and glaciers. The remaining water, less than 1%, is present in lakes, rivers, in the atmosphere, and as underground water. Let us now look at some physical properties of water. Water is a tasteless and odorless liquid at standard temperature and pressure. It freezes into ice at 273 Kelvin. Its boiling point is 373 Kelvin and has a density of 1 gram per cubic centimeter at 298 Kelvin. Water has strong hydrogen bonding in its molecules and, therefore, exists as associated molecules. Due to the presence of extensive hydrogen bonding in its molecules, water has a high freezing point, a high boiling point, a high heat of vaporization, and a high heat of fusion in comparison to hydrides formed from other group 16 elements, like H2S and H2SE. In comparison to other liquids, water has high thermal conductivity, surface tension, dipole moment, and dielectric constant respectively. And also, it has highest specific heat. These properties allow water to play a key role in the biosphere. Its high heat of vaporization and high heat capacities are responsible for the moderation of the climate and the body temperature of all living beings. Water is an excellent solvent for the transportation of ions and molecules required for animal metabolism. Due to hydrogen bonding with polar molecules, even covalent compounds such as alcohol, and carbohydrates dissolve in water. The shape of water molecule is bent or V-shape with a bond angle of 104.5 degrees and OH bond length of 95.7 picometers. In water molecule, as the oxygen atom has a higher electronegativity than hydrogen atom, it carries a partial negative charge, whereas the hydrogen atom carries slightly positive charge. As a result, water is a polar covalent molecule. In the liquid phase, water molecules are associated by hydrogen bonds. The crystalline form of water is ice. At normal atmospheric pressure, ice crystallizes in hexagonal form. The density of ice is 0.9167 gram per centimeter cube at 273 Kelvin, whereas water has a density of 0.9998 gram per centimeter cube at the same temperature. This makes ice float on water. In winter, the frozen ice on surface of the lakes provides thermal insulation and is important for the survival of aquatic life. Ice has highly ordered three-dimensional hydrogen-bonded structure, in which every oxygen atom is surrounded tetrahedrally by 4 other oxygen atoms at a distance of 276 picometers. Hydrogen bonding gives ice a rather open crystal lattice structure with wide spaces between the molecules. These vacant spaces can hold some other molecules of appropriate size interstitially. Chemically, water reacts with large number of substances. Let us look at some of these reactions. Amphoteric nature. Water is amphoteric in nature, which means that it can act as an acid as well as a base. According to the Lowry-Bronsted concept, water can act as an acid by losing a proton and as a base by accepting a proton. For example, in the reaction with ammonia, water acts as an acid by giving H+ ion and forming NH4+ ion. In the reactions with hydrogen chloride and hydrogen sulfide, water behaves as a base by accepting H+ ions and forming H3O+ ions. Water also undergoes autoprotolysis or self-ionization, in which one molecule of water acts as acid 1 and another molecule as base 2 to give a molecule of acid 2 and base 1. These are also known as conjugate acid and conjugate base. Redox reactions involving water. Water can easily be reduced into hydrogen by highly electropositive metals. For example, sodium metal reacts with water to give sodium hydroxide and hydrogen. Therefore, it is a great source of hydrogen. Water is oxidized to oxygen during photosynthesis. The reaction that takes place is 6 molecules of carbon dioxide react with 12 molecules of water to give 1 molecule of glucose, 6 molecules of water and 6 molecules of oxygen. It also reacts with fluorine gas to give oxygen and ozone. Hydrolysis reactions. Water is a strong solvent and dissolves many ionic compounds. However, due to its high dielectric constant, it has very strong hydrating tendency and can easily hydrolyze many ionic and covalent compounds. Water hydrolyzes the oxides and halides of nonmetals to their respective acids. For example, it hydrolyzes phosphorus pentoxide to give orthophosphoric acid. It also hydrolyzes silicon tetrachloride to hydrochloric acid and silicon dioxide. Water also hydrolyzes the carbides, hydrides and nitrides of some metals. For example, it hydrolyzes both calcium carbide and aluminium nitride to give ethine and ammonia respectively. The reactions that takes place are: calcium carbide reacts with water to give calcium hydroxide and ethine. Water reacts with aluminium nitride to give aluminium hydroxide and ammonia. Hydrate formation. Many salts can be crystallized as hydrated salts from their aqueous solutions. There are three types of hydrates. The first type of hydrate is coordinated water. For example, in Cr H2O6 3 plus 3Cl-, water molecules are coordinated to metal ions in a complex. The second type of hydrates is interstitial water. For example, in BaCl2 2H2O, water molecules occupy interstitial sites in the crystal lattice. In the third type of hydrates, water molecules are hydrogen bonded to certain oxygen-containing anions. For example, in CuSO4 5H2O, one water molecule is hydrogen bonded to sulfate ion, and the other four molecules are coordinated to give CuH2O4 2- plus SO4 2H2O. You have now reached the end of this module. In this module, you learned that water is a tasteless and odorless liquid at standard temperature and pressure. Water has strong hydrogen bonding in between molecules and therefore exists as associated molecules. Due to the presence of extensive hydrogen bonding in between molecules, water has high freezing point, boiling point, heat of vaporization and heat of fusion. It has high thermal conductivity, surface tension, dipole moment, dielectric constant and highest specific heat. The shape of water molecule is V-shape or bent. The high electronegativity difference of oxygen and hydrogen in water molecules makes it excellent polar solvent. The density of ice